Today we're doing section 7.2. It's actually a lot like what we did yesterday. We're going to look at some ratios. You'll have to simplify them, set up proportions. So it does go hand in hand with what we did yesterday. Now it's a little bit more geometry based, so there will be shapes and polygons, and you'll have to set some things up and solve for some missing information. But if you were good with yesterday, today shouldn't be too challenging for you. So our objective is to identify similar polygons. This is the last day of notes actually for this week. We'll take a little break and review. So if you can get through this, you'll be good. Alright, here is the definition for similar polygons. So they're figures that are the same shape but not necessarily the same size. So remember when we had congruent figures, they were the same shape and the same size. They were the exact same figure. And we had this same symbol but like with an equal sign underneath it. This one means they're the same shape but not the same size. So that is the symbol for being similar. When you have two figures that are similar, the corresponding angles are congruent and the corresponding sides are proportional. Remember, a proportion, we talked about that yesterday, it's just when two ratios are equal to one another. So we're going to write the side lengths in ratios, and we're going to make sure that they're equal to one another. And then all the corresponding angles should be congruent. So I'll give you a couple minutes to get these in your notes. There are 5 examples today, so it's kind of a quicker lesson. I'm hoping to give you some time to do that homework in class. Here's our first example. So remember, this symbol means that the figures are similar. So triangle LMN is similar to triangle RST. It's exactly like when we looked at triangles that were congruent. The corresponding angles are in the same position. So like L and R are going to go together, M and S are going to go together, and N and T are going to go together. That'll kind of help you position the sides so that the corresponding sides are in the same spot. So we have 2 questions happening here. Which angles are congruent? So we'll have some information about congruent angles, and then we'll have to write some proportions to show which sides match up. So let's look at the angles first. Which angle should be the same as angle L? Angle R, very good. And you can either sort of match them up based on the diagram, or you can just look at the order they were given. L was first, R was first, so those are the ones that are going to be congruent. Which one matches up with angle M? S, yes. And angle N? N goes with T, very good. Or again, just focus on the order they're given. L and R are first, M and S are in the middle, and N and T are in the back. So those are the pairs that go together. All right, that is extremely similar to when we did congruent triangles. So that shouldn't be anything like too shocking for any of you. Any questions on that? Okay, now let's look at the sides. This is where it gets a little different. So remember, they're proportional. So we're going to write some proportions. Proportions are ratios that are equal to one another. So I want to write a ratio using corresponding sides. So which side should line up with L, M? R and S. Good. So I'm just going to write a ratio. ML and SR. Or you could call it LM and RS. It's really up to you. They're the same thing. So again, you're just writing a ratio with the sides that match up, the corresponding sides. Okay, so that should equal, let's write another ratio. Which side should match up with MN? ST, good. All right, and then one more set of sides. LN goes with which one? RT, very good. Now, if you don't believe me, since this one actually has values, you could plug them in. So like ML is 18, RS is 12, so you could put like 18 over 12 equals 24 over 16 and reduce and see if it's true. It is going to be true, but if you don't trust me, you can go ahead and plug those in and check. But do you guys have any questions? Remember, the angles are congruent, the sides are proportional. So you just line up the matching sides, write them as ratios, similar to how we wrote ratios yesterday. And then proportions are just ratios that are set equals to set them equal to one another. Questions? Anyone need more time with this one? All right, here is example 2. There's actually a definition at the beginning. It's sort of hiding up above the directions. This is all about scale factor. So the scale factor, if you have polygons that are similar, so if similar, it's just the ratio of the side lengths. So you're going to write a ratio comparing the side lengths of the two figures that you're given. So we were writing ratios yesterday in like wins to losses. Do you remember that I said that order does matter on those? Whichever they asked for first needs to go on the top. That's the exact same thing here. So whatever triangle they asked for or polygon they asked for first, those numbers need to go on the top. The second one needs to go on the bottom. So we're just writing a ratio comparing X, Y, Z to R, S, T. So you want to start with X, Y, Z. Pick a side from X, Y, Z, any side. Your options are 6, 10, and 10. X is an angle. Pick a side. 10. Okay, we'll do this 10 over here. So that'll be my top number, 10. Now, which side matches up from the triangle RST? 15. It looks like it's this 15, like it's sort of flipped over. So that is the scale factor. Now, we always reduce when possible. Can we reduce this one? Yeah, 5 goes into both of them. What's 10 divided by 5? 10 divided by 5. What you got? 10 divided by 5. 2. What's 15 divided by 5? 3. So this is the scale factor. Now, remember I said it doesn't matter which sides you pick as long as you're picking the ones that are corresponding, the ones that match up. If we would have picked 6, for our top number, we would have had to do 9 for the bottom number. 6 over 9 reduces to 2 over 3. So no matter which sides you pick, once you reduce, the scale factor should be the same. The important thing with scale factor is to go in order. Okay, whichever triangle they ask for first goes on top. Whichever triangle they ask for second goes on bottom. What are your questions? Next, we'll look at example 3. So you'll see there are 2 questions on the board. Are the polygons similar? So yes or no. If yes, what's the scale factor? Pay attention to order here They're talking about B to A. Do you see how these are labeled B and A? So I'm always going to start with the B and then go to the A, just so that it's in the right order once I'm ready to write the scale factor. Now, for triangles or polygons in general to be similar, two things have to be true. The angles have to be congruent and the sides have to be proportional. So for part A, does it look like the angles are congruent? Like the little 2 matches with these little 2 over here, right? It looks like it's just like a trapezoid flipped over. See how these 2 match up with these 2? These 2 match up with these 2. So for the angles, it looks like we're good to go. What we need to check for is that the sides are proportional. So again, I'm always going to start with the B, and then I'm going to find the corresponding one from A. So if I start with 4, this 4 right here in figure B, that should match up with which one from figure A? The 2. Good. Okay. Now, we need something to compare that with. So let's just go to this 8. That matches up with which side from figure A? One of the 4s. Good. Now, this one's actually pretty easy because if you go to this 8, you'd have 8 over 4 again. Obviously, we have already had that written down. And then 8 over 4 again. You really only need to check it once since they're all going to be the same ratio. Does that make sense? Now, the way to see that this is true, there's actually 2 ways. You can find the cross product and see if it makes sense. So you can cross multiply, see if the numbers are equal. Or the way I actually prefer to do it is to just reduce the fractions. So 4 over 2, what's the number that goes into both of those? 2, right? 4 divided by 2 is 2, and 2 divided by 2 is 1. So that first ratio reduces to 2 over 1. Everyone agree? 4 goes into both of these. What's 8 divided by 4? What's 4 divided by 4? Do you see how they both reduce to 2 over 1 and 2 over 1? If they reduce to be equal, that means this truly is a true proportion. The ratios are equal. That means that, yes, these are similar figures. And if they're similar figures, we were asked to find the scale factor. Well, the scale factor is the side lengths written as a ratio and reduced. We just did that. So the scale factor here is 2 over 1. So that's why I said if you set it up with B over A when you're checking the sides, it actually does part of the work for you. You've already found the scale factor. What are your questions? If there are no questions, let's jump to part B. So, again, double check your angles first. If the angles aren't matching up, you've really got nothing to check with the sides. It does look like the angles are good to go here, so let's start checking our sides. I'm going to start with B. So the side length 5 corresponds with which side length from figure A? The 6. Good. That should equal, then I'm going to go to the 10. Should match up with which one from figure A? The 14. Good. So again, I'm always starting with figure B just because that's how it wants the scale factor. It just does some of the work for me. So I did 5 over 6 and 10 over 14. Now, you can either cross multiply and see if it makes sense, if you get a statement that's true, or you can just reduce both of these. Does 5 over 6 reduce? No, so I'm going to leave that one alone. Does 10 over 14 reduce? Yeah, they're both even numbers, right? What's 10 divided by 2? What's 14 divided by 2? 7. Does 5 over 6 equal 5 over 7? No, so these are not similar figures. And we don't care about the scale factor if they're not similar, so you're done on that one. What are your questions? All right, 2 more examples. These are the ones I like. These are the ones that I think you guys would be pretty good at. So the directions say the figures below are similar and we're asked to find y. Now in all the previous ones it told us like which triangle or which polygon to start with. This one is up to you. You can start with either one. If you want to put the bigger numbers on top and the smaller numbers on bottom, you can. If you like smaller on top, bigger on bottom, that's fine. You just have to do it the same way for all the ratios that you write. So do you guys want to do bigger on top or bigger on bottom? Bigger on top. Okay. So I'm going to start with one of these sides and the bigger one. 4. What does 4 match up with? What's the corresponding side for 4? What's in the same position on the other triangle? Y. So my first ratio is going to be 4 over y. That's going to equal, now we need to write another ratio. Since we started with the bigger triangle, go back to the bigger one, pick a side. I'll pick the 3 this time. 3 goes with 2. Now, all you need is 2 ratios to set equal. We don't really care about the third set of sides. Sometimes they don't even give you all 3 of them, so just focus on the ones you know. And just focus on 2 of them. So now that we have a proportion set up with our y, how are we going to find the y? So we did yesterday. We cross multiply. Good. So what is 4 times 2? 8. What is y times 3? 3y. Very good. And then I want to solve for that y value. How do I solve for y here? Divide both sides by 3. Now, this is tricky because we're getting that y equals 8 over 3. If you want to leave it 8 over 3, that's fine with me. Make sure the fraction is simplified. If it's improper, meaning like top heavy, that's fine. Or you can write it as a decimal. Whichever one you prefer, I'm fine with both. Does anyone know what 8 divided by 3 is as a decimal? 2.66666, so I'll round that to 2.7. So either one of those answers is fine here. What are your questions on this? Now, most of the work we do with similar figures is exactly what you see on the board. You're finding the missing length by setting up some ratios, making them equal to one another, and cross-multiplying. Questions? All right, last example of the day, then we're going to look at a couple problems from your homework, and then you'll be on your own. So again, we have 2 figures. Looks like we have some rectangles here. And now we're going to find x. Three over x, good. So these 2 line up, so that's our first ratio. That's going to equal what? If you started with the smaller one, you need to start with the smaller one again. So which number needs to be on the top? 4 over 6. That's a common mistake I see. People do like 3 over x equals 6 over 4. If you're starting with the smaller figure on the top, you need to make sure the smaller figure is on the top for all your ratios. All right, now we're going to cross multiply and solve. What's 3 times 6? 18. Good. What is x times 4? 4x. And then you need to solve for the x part. So what do? Divide both sides by what? 4. Actually, that does not divide evenly, so what you can do is reduce it. They're both even, so you can make it 9 halves by dividing top and bottom by 2, or you can write it as a decimal. Anyone know what that is as a decimal? 4.5. Yeah, 4.5. So either 9 over 2 or 4.5 is acceptable. One of these guys, okay? Don't leave it as an improper fraction that's not reduced. Reduce it. Leave it top heavy if you want. I don't like mixed numbers. They're just not my thing. So you don't see mixed numbers a lot in algebra, but if you do a mixed number, I won't mark it wrong. But I would prefer either improper fractions or decimals. Any questions? Alright, so you should all have a copy of this worksheet. It's homework 7.2 practice A. I want to look at the last section together. It's a unique problem that we haven't really looked at anything like this, so I thought it'd be fun to do it together. It says a square photo is enclosed in a square frame as shown. So you have a square inside of a square. Number 9 says, is the square formed by the photo similar to the square formed by the outside edges of the frame? What do you guys think? So we basically have two squares, right? We have a little square, that's the photo. It's 4 by 4 by 4 by 4 because it's a square. And then we have a bigger square that's the outside of the frame, and all those sides are 6. So are these similar? Well, I know all the angles in a square are what? 90 degrees, so these are all right angles, so the angles are going to be fine. Now, if you set up a ratio for the sides, it'd be 4 over 6, and 4 over 6, and 4 over 6, and 4 over 6. So are these similar figures? Yeah. And then it says explain. You could just say sides proportional, angles congruent, or something similar to that. Number 10, find the scale factor of the photo to the frame. Well, the scale factor is just the ratio of the sides as reduced as possible. So that would be 4 over 6. How can I reduce that? Yeah, divide both sides, or sorry, divide top and bottom by 2. So what would that give me? 2 over 3. That is the scale factor. Good. Number 11 says find the ratio of the perimeter of the photo to the perimeter of the frame. Perimeter is just the sum of all the sides. So if I add up all the sides of the photo, that's 4 plus 4 plus 4 plus 4. That's 16. The sides of the frame is 6 plus 6 plus 6 plus 6, which would be 24. And then can I reduce that?
It's 2 over 3.
Yeah, it's going to be 2 over 3 again. The ratio of the perimeters is actually the same as the ratio of the sides, so not too exciting there. And then number 12 is a really interesting problem. It says, are all squares similar? What are the two things you need to be similar?
The angle and the side.
All the angles are the same and all the sides are proportional. Will that happen with squares? All squares have what angles? 90 degrees. So the angles are fine. And then did you see what happened when we set up all the side ratios here? That will always happen in every single square. Whatever one of the ratios is, all the four sides will have that same ratio. That make sense?
Yeah.
If you think about it? Okay, good. So are all squares similar? The answer is yes. It's kind of a cool property of squares. So yes, they are. All right, you have the rest of the class to do 1 through 8. Let me know if you need any help.